I'm fascinated by how memories make us human, how we cling to good times, how a piece of paper can record a birthday or a little home that we have. Yet paper tatters and memories fade. So can we remember forever? Can we have memory that lasts? It turns out that we can, and we have. Our ancestors have done stone carvings that have captured their thoughts, that have stood the test of time, yet they are bulky. So can we miniaturize those carvings? Can we record our thoughts in atoms? That is where our journey began, a journey to make secure memory for India. My name is Udayan Ganguly. I'm a faculty at IIT Bombay in the Department of Electrical Engineering, and I lead this effort on the indigenous demonstration of semiconductor memory for secure applications.
This is the story of the first indigenous memory technology translation from lab to fab. Our team, in partnership with Semiconductor Labs Chandigarh, has demonstrated a one-time programmable memory technology. This is used for secure memories, hardware encryption, and artificial intelligence. We are glad to present our work at the IIT R&D Fair 2021. This presentation is created by Kumar Priyadarshi and myself, Udayan Ganguly, from IIT Bombay. Everyone today would like to have more and more memory drives in their phones. They need to store their beloved pictures, videos, and this need is growing in an exponential rate. Hence, memory innovation is today driving semiconductors. Every time you upload your pictures and videos onto the cloud, data encryption is needed to protect your critical private information. Artificial intelligence provides a new future that opens vistas of amazing possibilities. So commercial memory needs are driving business and innovation for memory technologies at the global scale. Strategic needs for India makes our own memory extremely critical. We need our secure identities for e-commerce, data security to store information in the cloud, and ultimately artificial intelligence that will make sense of it all. With secure memory being so critical, the question is, can India build its own memory technology? In this context, our team has recently done an important advancement. So how does this memory work? We have placed a nanoscale, in fact 2.5 nanometers of SiO2, which is about 15 atomic layers thick, insulator between two metal electrodes. Given that this SiO2 is pristine, the nanocapacitor does not allow the passage of any current. This is state 0. If at this point we introduce the equivalent of a lightning inside this capacitor, the insulator breaks down. This broken down insulator, this line being inside a solid material, is retained for perpetuity. How did we transfer this technology from lab to India's semiconductor fab? The story goes that in 2015, a PhD thesis contained the essential ingredients of making this memory. This idea was placed in front of SCL engineers who realized that this could be placed into their line. A collaborative effort was developed. By 2019, we were working vigorously as a team, IIT Bombay and SCL, to scale up our technology to 200mm wafers for production. By 2021, we had created a set of specifications to enable an 8-bit calibration or trimming application, and we had demonstrated a 97% yield in the fab. This is the major step to translate a technology from lab into semiconductor fab where it can be manufactured at large scale. The next step is to enable manufacturing of products based on these technologies, which will happen going forward. So essentially, this is a collaboration between IIT Bombay, which has a nanofab facility which is academic, and with our manufacturing partners SCL Chandigarh, and this is the meeting of the lab and the fab to create manufacturing innovation. This technology has taken a very long time from 2015 onwards and has been protected with funding from different departments like Department of Science and Technology, Ministry of Electronics, Office of Principal Scientific Advisor for different applications. It's also been helped along by fantastic collaborators from IIT Delhi, SETS Chennai and DRDO, again enabling different applications or serving with their expertise to enable different elements of capabilities. So now this technology is ready for production. How do we know this? Well, it has gone through multiple levels of manufacturing readiness level, starting with basic manufacturing implications identified, all the way down to step 8, where we have pilot line capability, and ultimately we are here at low rate of production demonstrated and capability in place for full rate of production. Hence, this is an advanced manufacturing level of 9, which is poised just before full rate of production. We also see that a variety of specifications have been achieved. You can see CMOS integration, early failure, program capability, read disturb capability, and retention. The worst case of which gives us the 97% yield for an 8-bit trimming application. This is indeed a major step that enables faith in the ability to produce this technology in large scale. So what is the value of this technology? This technology happens to have a total addressable market estimated at $140 million. A major application are government identifications like e-passport, which would be about consuming 40 million chips per year. There is mobile phones with near field communication and touchless, cashless transactions. And then there are secure NAVIC ICs, GPSs, and embedded systems for strategic applications. And finally, there is this whole vista of edge and autonomous secure AI chips for strategic applications. So this is indeed a large market for a new technology which is based on a secure memory. So India-owned technology and design enables national security. Our achievement was covered in the news and featured in key testimonials. The Office of Principal Scientific Advisor put out a press release that said that this is the indigenous memory technology adoption for 180 nanometer CMOS production, a national milestone in semiconductor R&D. The folks were featured on this. On the left, you can see the IIT Bombay team with Kumar Priyadarshi, Udayan Ganguly, and Ankit Bende. And on the right, you have the SCL team with Avinash Singh, Rohit Ranjan, Akash Sharma, HS Jatana, Deep Sahgal, and Tarun Malviya. In addition, there were other news coverages. The scientific leadership of this country also was congratulatory. In fact, Dr. Saraswat, member Niti Aayog, said that this technology will be a game changer by enabling secure memories and encryption hardware for the country. Professor Vijay Raghavan, Principal Scientific Advisor to the Government of India, wrote that the partnership between IIT Bombay and SCL to establish this memory technology for the first time demonstrates the augmented potential of semiconductor research in the country.
Now that this indigenous technology has been established, the next thing is to explore the rich plethora of applications that this can provide. So one of the first applications that you can do with this technology is to create a memory out of it. Now that memory will be based on breakdown process. That is stochastic in nature and it will be analogous to lightning. You can create a memory array out of it. So there are major applications of this technology and there are timelines to achieve these products. One of the major applications of this technology is trimming. What trimming does is it takes care of the deficiency that happens during the process of making a chip. Other applications of this technology would include something like hardware encryption, rad-hard memory, and neural chip based on OTP memory.
So the technology milestone has been achieved But the next thing is to put out applications in the strategic and the commercial space. And this is a journey that has to go out of the academic space into the commercial space. So we have a deep tech startup incubated in 2021 called Numelo Technologies, or Neural Networks, Memory and Logic Technologies for short. While this journey is daunting, we have wonderful partnerships with SCL, with DRDO, with some foreign foundries as well. Also partnerships with other academic and research agencies. We need to make products and we need customers, and hence we are looking for public and private partnerships to take this forward.
Digitization maps our memories into the electronic space. Aadhaar, e-passport are all our memories put together that represent us. Digital India is about putting those memories into the cloud. So where will our memories live? In distant lands, in far-off servers? Why can't India have its own secure memory? Why can't we have our information right here for this generation and the next? Our team is focused on achieving this objective because we have committed this to our memory. Memories are important because that's who we are, and as a country, we must have security in memories.